Alright, good morning everyone. The copy machine is not working, so I'm going to have to just write this on a piece of white paper. If you want to take notes on this, great. Otherwise, just stay tuned and then try and do the homework using this video as a tool. So this is going to be lesson 5.6. We've skipped a few lessons because it's factoring. It's all just factoring, which we've already touched on before. So we're going to be learning about complex numbers right now. Objective 1 will be identifying complex numbers. Alright, so let me get rid of some of these on the bottom here. First things first is we have to know what a complex number is. So we've dealt with normal numbers like 1, 2, 3, 4, and so on. We've looked at real numbers, which include both rationals, such as 1/2, and irrationals like the number pi. So now we'll expand our number system to include numbers such as the square root of -2. So up until now, we've always just looked at these numbers and said, oh, well, you can't take the square root of that, so it's done. Now we have a tool to be able to take the square root of this. It's called the imaginary number I. Okay, just because it says imaginary doesn't mean it's totally just made up. It is a mathematical tool, okay, so even though it's not a real number like 1, 2, 3, 4, it is a mathematical tool, like a concept, kind of like infinity, that we use to get us places. The study of electrical engineering, they use imaginary numbers a lot. Okay, so this is any number, so it is the number, imaginary number I, whose square is -1. So I square equals -1, and I equals the square root of -1. Okay, remember that there, that's really important. The imaginary number is any number of the form, so an imaginary number is in the form a plus bi, where b does not equal 0. If b equaled 0, you wouldn't have the imaginary number. Okay, so let's look at the square root. The square root of a negative number. So for any real number a, so let's take a real number, a, so like say a is 4, so the square root of -4 equals I times the square root of a. So let's break this down here. We start out with our, that should be inside here. We start out with our square root of a negative number. We can break this down into -1 times a inside the square. And then remember how we said that I is equal to the square root of -1? So I can pull this out here and turn this into I times the square root of a. So an example would be like this. We have the square root of -4. Okay, so that's equal to the square root of 1 times the square root of 4, which I can break down into the square root of -1 times the square root of 4. The square root of -1 becomes I, and then I still have my square root of 4. And then this breaks down into I times 2. That's a weird looking 2. Or just 2i. So the square root of negative 4 breaks into 2i. Okay, let's look at another example. So another example, we have the square root of negative 8. So we break this down into the square root of negative 1 times 8, which becomes the square root of negative 1 times the square root of 8. The square root of negative 1 becomes I, and we still have root 8. And root 8 simplifies down into 2 root 2. And then we just rewrite it with the number first, so 2i root 2. Okay. A few more examples here. So another example. I have the square root of negative 2. So then that breaks down into the square root of negative 1 times 2. So I can split those apart. The square root of negative 1 times the square root of 2. Square root of negative 1 becomes I. Then I'm left with root 2. This is prime, so I can't break it down anymore, so that's done. Okay, these are just a few examples to work with. I'm going to go on to the next thing here. So draw a big line here. Alright, so imaginary numbers and real numbers together, so imaginary numbers and real numbers make up the set of complex numbers. Alright, and then complex numbers, so complex numbers can be written in the form as a plus bi, where a and b are real numbers, and they can be 0. So a is going to be your real part here. This is the real part. This is just like any old number, 1, 2, 3, 4, etc. Plus bi. This is the imaginary part, because this contains the number I. Okay, I'm going to show you a diagram, just how this all works here. So we start out with our naturals, our natural numbers. So naturals, this is like our counting numbers, like 1, 2, 3, 4, 5, 6, 7, 8, 9. These are our naturals. That's on the inmost section. Above that we have wholes. So this is going to be our naturals including 0, so 0, 9. And then above that we have integers. These are our naturals, our wholes, and negative numbers. And then above that we have rational numbers. That comes next. So this is our integers plus fractions that have any fraction, like any integer in a fraction, that's a rational number. Okay. Next to that we have irrationals. So these are irrationals. And these are going to be your numbers that are just not friendly. So if you type them in a calculator, then the decimal is all, it just goes on forever. So if you could define pi as an irrational number, if you could define a rational, even if 8/3 you type it into a calculator, you'll get a bunch of decimals, but it repeats. It becomes 2.3333333, which is a pattern. If that decimal is a pattern, that makes it a rational number. Okay, so these are our irrationals. Outside of rationals and irrationals, we have real numbers. real numbers. These are basically all of our rationals and irrationals. So -5, -√3, 0, √5, 8/3, and 9. Alright, and then we can go beyond that. If you've ever watched Carl Sagan talk about the universe, it's kind of like we're starting on the Earth and we're slowly moving out. This would be Jupiter, Pluto. We moved out of the solar system. This is some other solar system. Now we're in our galaxy. Some other far, far away galaxy would be imaginary numbers. Okay, these are the new ones we just did. So -4i, anything with I. Okay, 2i√2. There's imaginaries. They're like our distant cousin. And then the universe would be all complex numbers. Remember, a complex number is defined as a real number, so a real number plus an imaginary number. So when you combine the reals and the imaginaries, you get a complex number. Alright, I'm going to stop this video. I'll start up a new one, and we'll move on from there.